All right, so I think this should be working. Hello and welcome. I'm gonna do some more Haskell programming. I'm hoping to get something that could be pull requested today. We've been working on this for 3 streams now, I think. So let's see how far we can get today. And yeah, so always say hi, or just say if there's if you've got a question or anything in the chat. I'll try to keep an eye on it. So what we've been working on for the most part, or what I've been working on, is teaching the IDE about a file format that the compiler has started using recently, that lets it keep note of when certain files were compiled and what content hashes they had when they were compiled. Hello Rob, how's it going? And so the idea here is that the IDE has a rebuild command which rebuilds single modules, but it doesn't know about that file format yet. And so right now it's actually possible to create situations where the compiler doesn't know how to invalidate its cache anymore. And so I've been working on fixing that basically. And once I fix that, we can actually see if we can use that cache file to get some better cache validation for the IDE server on top. Because I've been relying on file watching there, and that has just been way too flaky, and I prefer to not be doing that anymore. All right, so this is the thing we've basically been working on. And so what this does is that this is when the rebuild command of the IDE server runs, this is now going to write out the updated information. Hey Sam, how's it going? Nice. Right, yeah, so let's see if we can see how that looks and what this does. I think I have a directory somewhere here that we've been using as, okay, this is the one. So that we've been using as our playground for this basically. And so this cache file lives at output catchdb.json, right? And so if I were to now go and delete the output here, and let's say compile everything inside source, what it's going to do is it's going to write out that catchdb file down here. And as we can see, these are the paths. So this is an FF5 file, this is the source file. And it writes out when the timestamps of when that file was last written, like what the timestamp of the file was when the compiler compiled it the last time around, and the content hash of the content of that file. Right. And so what we've done now is if I go in and I say, let's open this file in our editor, and I'm going to start up the IDE server here. Okay, and I'm going to make a change to this and save it again. And this has caused the IDE to recompile this. So if we look at this again now, one thing we'll see is that there is a file mismatch here, in the sense that this path is different from this path. I'm wondering why is source main no longer in here? Did it somehow still match these two? Maybe. Maybe it did. Anyway, so this is now new, and we're writing out a timestamp that is nonsensical, because what we're saying is the IDE can rebuild files that the user hasn't saved yet. So the timestamp is not a good metric for to tell the compiler that when this file was last changed, because we might have rebuilt some in-flight state. All right, yeah, that's cool. Yeah, I mean, I've been doing this for a while now, but I've got good day and bad days. I'm trying to be explain what I'm doing, but it always helps if there's someone in the chat, so I know that I'm not just talking to myself. So that's nice. That's cool. Yeah, I'm looking. I mean, that would be great. I'm looking forward to seeing some more Haskell streams, especially on semantic and type checking. So, and I think you're the two guys for that. So that sounds good. That's cool. Yeah, I can do. I mean, I could do a bit of a demonstration of the PureScript IDE tooling we have, but I think I've done a couple of those already. Anyway, so what we've been saying is we have these timestamps. Okay, and so yeah, so because we might be compiling state that isn't persisted to the file state yet. Sorry, just need to let my cat in. We're not writing out the we're writing out a bogus timestamp, but the content hash is the bit that is important, and so the compiler could use this to figure out whether or not it needs to rebuild. All right. I mean, I totally Starlight. I don't even know what that is, but that sounds exciting. Is that more effect system stuff? All right. Anyway, so we can use the content hash. So if I change this back to 43 now, and I save this file again, and I call out to this again, we see that this is the new content hash for main.pers. And that's the same we had before. So the compiler could use this to figure out that it does not need to rebuild the file if it found that on the next subsequent run. So that's all working well. The thing that isn't working particularly well is the fact that this file path has a totally different format from this one up here. And I'm worried that we might get into situations where this lookup, where we end up with both of these file paths in the same map. And so what we should be doing is we should be normalizing these. And the strategy I've concocted, or I've decided to implement here, is that we're going to do we're going to follow two rules. So what we're going to do is we're going to say any path that is beneath our current working directory will be stored as a normalized relative path. Any path that isn't will be stored as an absolute path. And one thing we're not going to worry about now, for now, is file path separators. There's certain situations where that could be relevant. If someone was developing on a development container on Windows or something, so they had like the compiler running inside Linux, but we're using some IDE tooling on the Windows side. But I'm not going to worry about that for now. We'll see if that's something that comes up at all. All right. So now the thing is, we kind of need to figure out where we're going to do the normalization of file paths. And the file path that is relevant is this one over here. And what we might need to do is we might need to hide the cache info constructor and write some smart, or like some wrapping getters for this map. I'm wondering if we should be doing it in the ASON instances instead. Well, I mean, we can't do the thing where we look up the current file path, so that's probably not something for the JSON instances. So let's see where we construct these cache infos, I'd say. So rebuild status, okay, where is that being populated? Get rebuild status, that's where we're getting it. Just down here. Question is, where is that being written? is there any cache calls to the cache info constructors in here? No. Okay, so where is this being constructed? It might actually be constructed in here. Check changed. Yeah, this is outputting a cache info. Right. So maybe we could be doing this in here. So far this is just using monad, but I'm sure we could be adding a monad IO here, and that would be fine. Or we could be taking an extra argument to say, give me the base file path. So this is the module name, and then we could be taking another file path, which would be the base path. Let's see what check change is called. So the call is in here. All right, so wait, where is that? Check change down here. Okay, and this is run inside construct, which lives in something that is good enough for us to do IO in. So we could be getting the current directory in here. I think that's actually what I'm going to do. Yeah, I think check changed is going to do this normalization of file paths. So where is the file path coming from? It's coming from over here. My cat wants to go outside again. I think he just wants the attention. All right. So, where are we constructing these? Constructing them in every single one. So maybe we can actually do the thing up here. So let's say what we want is a normalized file path. And now we're going to need to use some of the functionality inside the file path module for Haskell. So let's look that up. Okay, so we definitely need to check whether or not the path is relative. So that we can start with that. So, well, so if it's a relative path, we're just gonna normalize it because there's nothing we can do here, I think. So let's think of that. Is relative. Then, and we're gonna call normalize. Do we have file path in here already? No, we don't. Let's import that. File path, add file path. And I think we might want the, oh wait, file path is in scope always. We might want the concat operator unqualified, but we'll see about that in a second. So if the file path is relative, then we're just going to normalize it. Otherwise, so I'm just going to write this out in pseudocode and then we can think about it. So what's the two cases? So else if fp something like is relative to the base path, then we're going to make it relative to it. Can I do that? Let's format this a bit differently so it's a little easier to see what's happening. So if it's relative to the base path, then we're gonna, and again, I don't know if this is the correct syntax, function call, but we'll figure it out in a second. This is just pseudocode for now. And otherwise, we're just gonna leave it as absolute. So we're just gonna ignore it. I like this. We might still wanna call file path.normalize though. I think. Okay, so let's find out if there's something like make relative. So So this is the normalize function that I've been using in a couple places. So make relative takes the base first. So make relative actually exists, so that's good. Is relative, is there a, how do we figure out whether or not one file is relative compared to another one? What does make relative do for two paths that are not? Okay, so it just leaves them leaves the file as absolute if it doesn't work. So what if we did this? So let relative path equals file path make relative, like so. And then what we're going to say is if relative path is relative, is relative, the relative path, then we're just going to normalize it. And I'm assuming that make relative actually already does the normalization, I'm still going to do it anyway. So relative path. Otherwise, we're going to do this. And I think this is, so we're going to add a comment, a little comment up here. If the path is still absolute after, let's actually add that down here. If the path is still absolute after trying to make it relative to the base, that means it either was, no, that means it is not underneath the base path. That can probably improve that comment, but it's just good enough for now. Someone is going to probably figure out the nicer way of saying this in code review. So does that capture our rules? What were our rules again? Just going to move them over here. And then we can figure out if we've implemented them faithfully. Any path that is beneath our current working directory will be stored as a normalized relative path. So if the path is already relative, then we're just going to normalize it. If the path, so the else branch here, this is dealing with absolute paths. If the path can be made relative to a base path, then we're just going to return that, which is this thing. And any other absolute path will just be stored as an absolute path, which again is going to work out here. So I think we're good. I'm just going to leave that comment in there. I might take that out later, but it's good for now. It might help the reviewer, and I might get some good, figure out a better algorithm for doing this. Okay, and then. Okay, so let's see what this does to the paths that the compiler outputs. I think I might need to kill the running IDE instance because that is probably not allowing me to copy over the new executable. So let's do this first. And I'll pour a coffee while that's all right. So. Yes, that's true. File path.normalize. Where is file path coming from again? Oh, we can't do that in here. We need to move the whole block in here. Is there a where block here? No, there's not. I'm gonna put it in the where. I might just move this into top level definition. So let's move this a little in there. I'm just going to take a file path as an argument. and a base path as well, even though now that we've got that up here. So all right, so what we do is we say let, and now I can't shadow this, unfortunately. What I could do is I could use a view pattern here, do this. I don't love that. I might change that, but I'm gonna just say that's good enough for now. I don't even know if that's turned on for the compiler repo. We'll see in a second. So relative path. Yeah, that's missing an E. All right, have a typo in there. Yeah, there's a capital P. All right, and so now we need to update the call side for check changed to also pass in the base path. We do that up here. So I think we can just do this. We'll figure it out. So get current directory is the call, and I think we might need to lift IO that. Is there any IO going on here other than that? No, there's not. We'll see if that works in a second. I think that is system.directory. Let's see. Okay, so we need someone at IO or something. This is the most annoying part about Haskell for me, is all the imports and the slow compiler, but because in PureScript I don't care about imports anymore. I just the IDE just inserts them for me. So control monad io.class. All right. So that looks good. So now we can update this call to, in which order does it take the paths? Module name base paths. All right. And so it doesn't like that because I haven't added the monad IO up here. Now there's probably a way to do the monad. I don't know how to do that anyway. Glad you like it, Tomasz. Thanks for hanging out. It's just saying is stack on GHCID next weekend. The problem with hacking on GHCID is that I'd need to do it in Haskell. Also, there's a couple of very capable people on that. I think they'll probably implement that before I can get to it. So now the whole monad IO thing is going through. So there's probably something I can do with the monad base control thing there. But we'll see if I can just add the constraint for now, and then okay, there's more monad base control stuff going on here. I'll have to look up how to do that. Where's monad base control? So lift base width. So I'm just looking for some IO in here. Okay, so I'm assuming that it's something. Do we have lift with anywhere in here? Nope. It's not lift with. Is it lift base with? Okay, so we've got stuff in here. Method base control IO make. So can I just use lift base with them? No, this just implements it. Where is this thing actually used? Okay, maybe I can just look at this and find like some place where it's doing IO. So this is make. So this is modifying M bars, which is certainly IO. Is this just doing IO in here? C.read mvar. Where's that coming from? Concurrent lifted. Okay, so this is already lifted stuff. Damn it. I'm just gonna add a mode.io constraint, but I don't think that's the right thing to do. So I'm gonna add it to do the don't remove the mode.io constraint. So like, someone needs to figure out how to do this with whatever. Okay, so now we've got the new executable. So I'm going to delete the output. I'm going to run the compile again. I'm going to start with this one. We're going to check out the catch.db.json. And one thing we can already see is that it no longer prefixes the path with the // thing up here. Right? So that's already a win. Because that means that, because before we did this, if I'm going to remove the output again, if I compiled this using this glob, it wouldn't find any of these files as having already been compiled. But now if I compile this again, I'm hoping it doesn't recompile anything here, but I'm not entirely sure. It might just skip these, or it might actually be recompiling these. That would be bad. How do we find that out? Well, we can revert our change, I guess. Or we could, let's figure this out. We could, oh yeah, we could not do a thing. Just have like an unused function in there. So let's install with the old behavior. We might need to change the lookup to also do the normalized lookup. We'll see in a second. Okay, so that was that. Just noticed the typing Haskell and Haskell bookmark. Yeah, that was kind of a nice. I mean, obviously it's not by Chris Dunn, but The markdown version of it was nice to work through. Though I'm firmly in the bidirectional type checking camp by now. All right, so we did that. Let's remove the output, step 1. Let's compile with this. And now let's compile like so. Okay, and so it prints the output for both of these anyway. I'm not sure if it's doing work though. I mean, it shouldn't be, right? Is the caching not working? When is compiling? Render progress message, right? Render progress message. What is that called? Now we need to look for progress. Down here, does it figure out whether or not it needs to be rebuilt at all? Or does the build plan stuff already figure out whether or not to call rebuild module? That's the thing I'm curious about. Now this calls only for those that need to be rebuilt. It's called build module. Let's see if we can find out where that lives. Let's define down here. And this calls rebuild module. So right now it seems to not honor the cache at all. Curious why that is. I'm doing something wrong. What happens if I... Okay, so it doesn't do anything. So was this broken all the time already anyway? No, this is the behavior we had before. This is the behavior I expected. So yeah, it recompiles if I change the files in the file paths in a way that doesn't actually change the file path, but makes them look different. Okay, yeah, and my hope was that our change would make that go away. So, okay, so this does not rebuild. But if I do this, this still wait, what? So it's doing the thing again. Oh yeah, of course. Ha 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 ha. I need to bring our change back. Cache. Okay, so that's our change back in action. Oh. All right. So delete the output. Rebuild like so. Okay, so this constantly rebuilds, and this doesn't rebuild ever because, well, it has normalized these file paths to look like this. So the thing that's missing is that the lookup needs to normalize the paths before it does the lookup. So check changed is called where so it aligns the DB info with current info. Current info, and that's this file path, and I have a feeling that we need to change the way that is populated. What is check changed called? It's called here. This is the cache info. This is being created by get input timestamps and hashes. And again, having an actual go-to definition would be so much nicer than having to do this by hand. So let's define up here, right, and extracted that into its own thing, which is up here. The file path to the PureScript module to the potential FFI implementation. Right, and so what we need to do is we'll need to normalize these, I believe. The question is, do we do that in here? Do we do that somewhere earlier? I think we do it right here, actually. Let's actually do it. Wait. One question is if we do the same kind of, if we want to do the same thing with the base path. Oh, we can do it here anyway. We've got monad.io around. Is it all right to do it here? I think that's fine. All right, so let's actually make this a thing. Let's make this a function that exists in the cache. All right. And so what this does is normalize for cache, and it takes a base path and a file path and returns a file path. And I'm going to add this as a documentation comment here for now. Again, we might decide that. Oh yeah, this is Haskell, so I need to do this, right? No, this doesn't. Yeah, it works. Yeah. So this might not be the most descriptive one, but we can figure that out. So normalize for cache is now a function that is exported from here, and we need to change this to be normalize for cache base path. Right, and so now what we should be able to do is we should be able to go back in here and say, give me the current working directory. And again, that might need to be, nope, get current directory is called already. Okay, we're calling that down here. And I doubt that that's ever going to fail, so I'm not going to add error handling to that. Yeah, if that fails, I don't know. Okay, and so what we do now is I think we can do this, right? Yeah, we can just map cache dot normalize for cache of current working directory over this. I think we might need to add an import. Now it's imported unqualified. Okay, so let's see if that works. All right, so that worked. So let's remove the output and recompile and recompile and recompile. Okay, that doesn't do anything. Let's recompile, and that doesn't do anything either. Let's start by compiling like so, and now we do this. That still doesn't do any work. So that seems to be working. So that's nice. So let's make a little commit with just that change. Oh yeah, I want to get rid of the monad.io constraint somehow. Why did I need that again? I did IO in here to get the path. Wait, I'll figure it out by just looking at the div. So I changed make because I changed this. No, this was already in IO. Oh, the build plan creation. Right. Is that something I want to pass in here? I don't think so. Constructs a build plan for the given module graph. This is monad. I have a feeling that monad-based control IO should give me the ability to just do IO. All right, Rob. Thanks for hanging out. Really looking forward to your stream. Have a nice day. All right. So, is there any tutorial if I just Google monad-based control? Is there anything? Okay, so let's try this one first. Is there a, should I be doing lift base? Is that the one I should be doing instead? I don't know. I'm gonna try and see what happens, I guess. It's not in scope. Lift base, that's probably gonna be control monad trans control. Wow. Oh, there it is. Lift base. Does not export lift base. Okay, so where's lift base from then? Does it exist in here? Lift base with. Lift base with. I really don't want to lift. I might just ask over here. What do I? Let's see. We might be lucky and get a response there. Until then, I'm gonna stick to the whole lift IO thing, I guess. All right, so thanks for hanging out. And I'm really looking forward to your streams as well. Give me some nice type checking, please. I'm collecting timestamps though, right? So timestamp, get input and timestamp. So I'm just calling this get input timestamp and hashes. But that's because make is a monad base control thing. Oh, I think I know what I can do. Oh, I think I know one thing I could do anyway. When am I doing the get current directory again? Down here. I could do a make IO instead and do something like getting the current working directory. Which makes which lifts the whole thing into make. I don't know. I don't have an answer on that. So make IO. Why is that not around? Do we need to import that? It's from make monad. Make build plan. I'm gonna do make.monad. Make IO. Let's remove this. Let's remove this line and see if that works. Nope. Oh, make IO still needs. Interesting. Make IO still needs monad IO. So do I need to force it to actually create a make for me so that I can then use some monad base IO makes it so that lift base is just that. Where's lift base coming from? Control monad base? Maybe I just needed to import that one. So, oh, so does lift make IO in here? And then that's in, no, that's in make actions. So maybe control.monad .base lift base is what we need to do here. Make IO. Make IO. Lift base. Oh, come on! Just think about how easy that would have been with a proper auto-completion that just inserted that for me. One thing we could try is see if the type tool machinery in Haskell can figure this out. That'd be kind of cool. Let's see if we can. Valid whole foods include lift base. That's so cool. Yeah, so I should have done that, I guess. So, okay, so let's see what other signatures I changed that I didn't need to change. So I'm not going to worry about this bit at all. So how did I change make? I'm just going to update this buffer to make sure. Okay, so how did I change make? Like so, yes. And I'm going to get rid of that, and I'm going to get rid of that. And ideally that means, yeah, okay, so now we don't have any changes in the main make module anymore. So this is just doing the check and passing that one through, so that's good. This is the normalize for cache functionality. And this gets the current directory and normalize the file size before doing the lookup. And as far as I remember, let's make that commit first. So normalizes file paths before inserting them into the cache. So that's good. So now if I go into rebuild, I think I'm already doing the get input timestamps and hashes, but maybe I'm not. No, I'm not. Get input timestamps and hashes prime. That's the one I generalized. So where am I calling that again? I'm not calling that yet. Was the intention to actually call that, and I don't yet. Maybe it was. Let's figure that out. So what does this do again? This gets the timestamp and hashes the file. Oh, but I decided that I didn't want the timestamp anyway, right? Is this why? Yeah, because this does the file hashing. I might do this anyway. I'm just gonna leave it as is now, and I'll figure it out. So we did. No, we didn't do that yet properly. So rather than calling make relative here, I'm gonna call normalize for cache. Make relative. Then let's normalize for cache. Like so. Okay. All right, so now we install this again. We're going to remove the output. We're going to compile this once. This is the file path for main. So now we're going to open up main.pers in the editor. And we're going to start up the IDE integration. And we're going to change this, rebuild it. So, and now we can see that this is the correct format. So this is exactly the format we wanted. And this has changed the content hash accordingly. So if I change this back to 43, we should be seeing the 3B5A7, which is the same 3B5A7 we're seeing up here. So that's good, so that's working. One more thing we want to make sure real quick is that this also works for a JavaScript file. So I'm just going to rebuild this thing and see that this has updated the file path for the JavaScript file as well. It has, and this looks like the correct path. And now after I've done that, I should be, it did just recompile main. So why was that? So I did not expect it to have to recompile main here. 3B5A7. So why did it recompile main? Did I change anything about dip? I don't think I changed anything but the file timestamp. Can I make it reproduce it? No, okay, so it doesn't do anything here. Well, I'm gonna save this file. Doesn't need to recompile. All right, that works. Go into dep, change this to say X, and it recompiles main. I think what's going on here is that while it uses the content hash correctly to determine that it does not need to rebuild dep, it uses only the timestamps to determine whether or not to rebuild main, is what I'm thinking. Yeah, because this is updated by the compiler now. Interestingly enough, these are updated as well, even though I didn't change. That's interesting. What happened there? I'm gonna change this. So now when I check, these are the file paths. I'm gonna hit the compile again, and it actually updated the timestamps of these files. All right, so that's new, I'd say, or interesting at least. So we'll figure out what's going on here. I think that might be a good thing, updating these timestamps. I'm not sure why it determines that that means that it has to rebuild main though, because that seems like a bug to me. So I think that's probably, that happens when it constructs the build plan. So where does it figure out whether or not a module needs to be rebuilt? Collect pre-built modules. So it seems to only be using the modification time to figure out whether or not a file was pre-built, rather than using the content hash as well, which might be a bug, I'm not entirely sure. But I think I'm gonna call it a day for now for here. I did the thing I wanted to do, which was making it properly normalize all the file paths, which it does now, and that works. And so what I'm gonna do is I'm gonna commit this change, and I'll get back and figure out why the compiler isn't using the content hashes to figure out whether or not a module's dependencies cause it to rebuild. I'm going to change this. I'm going to push this chain. I'm just going to add a little to do so that I remember what I need to do the next time around. So I think I'm going to add that into my rebuilder file here. So that worked. I just need to add a new to do. Figure out why the compiler doesn't use content hashes to determine whether a module needs to be rebuilt. That's not entirely true, because it does use content hashes, but only content hashes for a module's dependencies. For a module's dependencies to determine whether that module needs to be rebuilt. Figure out why the compiler doesn't use content hashes for a module's dependencies to determine whether that module needs to be rebuilt. Okay, yeah, that comment seems to make sense. Modules are strictly content hashes, or do they contain also input hashes as well? No, there's strictly content hashes for the files. There's no like Merkle tree stuff going on here. So this is strictly a content hash for this file. All right, Thanks for hanging out. That was fun. I think I made some decent progress here, and I might do some more later, but otherwise I'll probably stream a bit more tomorrow. Thanks for hanging out. Have a great day.